Okay, so in this example here, we're going to be talking about how to solve complex equations. Now, this really is pretty straightforward. All you have to remember is that you need to keep the real parts together and you need to keep the imaginary parts together. And this goes back to a complex number. So when we're talking about complex equations, we have a real part and we have an imaginary part. Well, that's the same deal with a complex number where you have a real part, A, and an imaginary part plus BI, okay? So another way to look at these equations is the following way. You can look at it in terms of a complex number. So first determine your real parts on both the left-hand side and the right-hand side. So for example, on the left-hand side, 2x is a real part. So this part right here is real. We're going to call that A, okay? Going to the right-hand side, well, 4 is real. I'm going to go ahead and call that A. So you want to keep your A's together. And then going back to the left-hand side, 3i is imaginary, so we're going to call that bi. And then negative 5iy is also imaginary, so bi. So again, a is going to be equal to a, and bi is going to be equal to bi. Okay, so that's all you really have to remember. You're going to keep the real parts together and the imaginary parts. And again, just think about a coordinate grid, and in particular, a complex coordinate grid. If you have a complex coordinate grid, so real quick here, right? On your x, so on my x-axis, I have the real numbers, okay? These would be real. And then on my y, I'll have the imaginary. So imaginary, right? Go ahead and write that in. So again, on your x, you have real. On your y, you have imaginary. Again, that is a complex plane. The point being, you need to differentiate between the two. I don't want to combine my real numbers with my imaginary numbers because, again, they're on two different axes, right? Reals will be on the x-axis and imaginary will be on the y-axis, right? So that's another way to remember it. But again, all you have to remember, keep the real parts together, keep the imaginary parts together, and you will be good. So let's go ahead and set this up. How is it going to look? Let me get rid of all this here. So you're actually going to get two equations. Your first equation is going to be 2x and then equal to 4, okay? Those are my real parts. I'll solve for x and I'll get my answer there, right? Now, doing my imaginary parts, I get 3i equal to negative 5iy, okay? So let's do the real equation first. Divide both sides by 2, okay? And you get x is equal to 2. Done, okay? Easy. And now working on the imaginary equation, I'm going to divide this side by negative 5i, okay? So both sides by negative 5i, cancels. Again, your i's will cancel. You get y is equal to negative 3 all over 5. And that's done. Okay, so pretty straightforward. So you don't have to go ahead and rewrite everything in terms of A and BI. You don't have to do that. Just remember to keep your real parts together and keep your imaginary parts together. All right, let's go ahead and try another example. So here's our next example. Same thing. We're just going to keep the real parts together and the imaginary parts. But before I do that, I need to go ahead and simplify down this equation. I need to take this I and I need to distribute. So I'm going to get ix and then plus 2i minus 5 equal to y and then plus 2i. So let's set up the equation for the real parts. Looking at the left-hand side, I have negative 5 equal to, and then looking at the right-hand side, well, I have a 1y, right? Technically, there's a 1 here. So that would be considered our real part, 1y. Or in other words, just y. And that's solved. So y is equal to negative 5. That was easy, okay? Doing the imaginary part, you get ix plus 2i and then equal to 2i. All right, so how do I solve this one? Well, why don't I go ahead and subtract 2i on both sides? Okay, what happens here? This will cancel. This will also cancel. I get ix is equal to 0. And then all I have to do from here is divide by I. And we know that 0 divided by anything is 0. So x will be equal to 0. And that's done. All right, let's go ahead and try a few more examples. All right, here's my next example. Same thing. We want to simplify it down before we do anything. Distribute the 4 here. And then distribute the 2 here. Okay, and then let's rewrite it. 2b. And then plus 4xi. And then negative 8. Equal to 2xi. And then plus 10. So let's set up our real equation first. Looking to the left, I have a 2b and a negative 8. So I'm going to go ahead and write 2b and then minus 8 equal to, looking on the right-hand side, I have plus 10. So I'm going to go ahead and write plus 10. So there's my real equation. All right. If we solve this one, I have to add 8, both sides, right? I get 2b is equal to 18, or in other words, b will be equal to 9. B will be equal to 9. All right. Then doing the imaginary equation, I'll get the following. I get 4xi, again, working on the left-hand side, and then equal to 2xi, okay? So from here, I'm going to go ahead and move over 2xi to the left-hand side. So I get 4xi, and then minus 2xi, all equal to 0. These are like terms. I'll get 2xi equal to 0. So again, I'm trying to solve for x here. I'm going to divide both sides by 2y. That cancels, but I also have to do it here. Divide by 2y. Well, same thing. 0 divided by anything is 0. So x will be equal to 0. Done, right? All right, let's go ahead and try one more example. So here's our last example. We're going to go ahead and take I and distribute here. Make sure we simplify everything down first. So we get 2x and then plus 5yi and then minus 2i and then equal to 5x minus 2yi. Okay, so we want to look at our real parts on the left-hand side. That's going to be 2x. So 2x and then equal to the real parts on the right-hand side. That will be 5x. Okay, let's go ahead and solve this equation. So again, it looks like we're going to get another 0 here, but let's just go ahead and prove it out. I'm going to go ahead and move over this 2x to the right-hand side. So I get 0 is equal to 5x minus 2x. I get 3x. And then finally, dividing both sides by 3. 0 divided by anything is 0. So x is equal to 0. Okay. All right, so now let's go ahead and do it for the imaginary parts. So setting up our next equation, we're going to have 5yi and then minus 2i and then equal to negative 2yi. Okay. So from here, I can see that I have like terms here and here. I'm going to go ahead and move over this positive 5yi. That will be negative 2yi minus 5yi, right? So rewriting it, you get negative 2i equal to, and then when I combine these like terms here, again, it's negative 2yi minus 5yi. That will give you negative 7yi, right? So I get negative 2i equal to negative 7yi, okay? And then from here, I want to solve for y. So I'm going to divide both sides by negative 7i on both sides, right? And so as always, the i's will cancel out. My negative 7s will cancel out. Same thing over here, my i's will cancel out. Now I'm dividing by two negatives right here and here, so the end result will be positive. So y is going to be equal to 2 all over 7, and we're done. Okay? So that is solving complex equations. It's pretty straightforward. All you have to remember, keep your imaginary parts together, keep your real parts together. And so you should have a total of 2 equations when you do that. You'll end up forming 2 equations, then solve for the variable in each one of those equations, and you're done. All right. So I hope that you found the video helpful. I hope that you gained something from it. If this video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.